Hello and welcome to a training session on the rainwater harvesting design specification pre-tank rainwater system. My name is Jackie Hammond. I'm the CEO from Blue Mountain Co and I'm a member of the Rainwater Harvesting Committee, which is a committee within Irrigation Australia. With rainwater harvesting systems, the first thing to understand is, as a whole, a correctly installed rainwater harvesting system develops a natural treatment train, and this addresses many of the potential contamination issues that may be associated with a roof catchment. This is an important reason why rain harvesting is used so widely in Australia and rainwater users remain healthy. The Rainwater Harvesting Committee, with Professor Peter Coombs from Urban Water Cycle Solutions and other independent scientists, have extensively monitored the inputs and outputs of residential rainwater harvesting systems and use this data to inform the design specification. It's important to understand that the components of a rainwater harvesting system, from the roof to the house, need to be considered as one entire system. You can't only do one component. It's really important to ensure that all components are installed as a part of the system to ensure that you get the right outcome. Number one is the roof. So maximising the roof area collection. Research has shown that better yield outcomes come from specifying a minimum roof area. It is really important that you install the maximum roof area you can and have that directed to your rainwater harvesting system to maximise the yield. The minimum roof area that should be connected is either 100 square metres or 50% of the roof area, whichever is greater. And a properly installed roof guttering system on a standard roof will connect approximately 100 square metres of roof catchment to the rainwater tank via 2 downpipes. A choice to connect more roof area may involve you installing a charged downpipe to connect to the rainwater tank. And just to explain, a charged downpipe is where the downpipe goes underground, and charged means that it still has water retained in the downpipe once the rainfall event has occurred. The other thing that's really important to consider is using lead-free roof sealing materials. Some existing roofs may have lead flashings on it. It's really important to inspect your roof surface and make sure that any lead flashings are removed. It's also important to make sure that non-corrosive materials are being used. So inspect your roof to see if there's any fixtures installed on the roof. Make sure that any of those fixtures are non-corrosive, and for instance, if you have an old galvanised roof, have a look at where the screws and the fittings are. Make sure that none of those have corroded. If they have, it's a pretty simple matter to be able to replace them. The next thing to consider is the roof gutters. Now, all roof gutters need to be designed to the building code and the Australian standard AS 3500, which is the plumbing and drainage standard. And all roofing guttering should meet these standards as a part of building design anyway. Meeting these standards will ensure that your gutters are sloping towards your downpipe. It's really important, obviously, that your gutters slope in that direction, that you know that, to ensure you're maximising your collection of rainwater. The direction of the gutter fall, if you want to check that, you can do that by putting a hose in the gutter to see if the water flows to the downpipe and not away from it. If you have any water that ponds in your gutters, you'll need to get those gutters corrected to ensure that you have the fall to the downpipe. The other thing with your gutters is to ensure that you keep them free of debris. Clogged gutters will prevent water flowing to the tank, and it will also affect the quality of the water. For safety and convenience, you may want to consider looking at options to minimise your maintenance, for example, installing products like gutter guards. Gutters can also be specifically designed to maximise rainwater collection, and it's also important to consider the size of the downpipe that you're installing, which we would recommend is ideally 100 millimetres. This ensures that you maximise the rainwater that you're collecting. The next thing to consider is the rainhead leaf diverters. So it's important that rainhead leaf diverters are installed on all downpipes that are connected to your rainwater tank. And what rainhead leaf diverters do is they ensure that leaves and debris, as well as insects and animals, such as maybe frogs, can't access your downpipes or your rainwater harvesting system. So rainhead leaf diverters include screens. to filter out all leaves and debris over 1 millimetre, and this prevents blockages, discoloration of your rainwater, and debris breaking down in your rainwater and your downpipes. It's important to ensure that your leaf diverters are installed in an accessible position, but they also need to be above the entry point to your rainwater tank. That's to ensure that you have a downward flow to your tank, so the water will flow to your tank. And also you need to be able to access them to ensure that the screens are kept clean and free of debris to ensure they work effectively. The other thing to check is to make sure that you have 316 stainless steel mesh on your leaf diverters. This ensures longevity. It's also important that one of the screens is less than 1 millimetre. Typically it's 0.955 millimetres, and this size aperture ensures that small insects such as mosquitoes can't enter the system and breed in any water that may be sitting in the downpipes or in your rainwater tank. First flush diverters is the next step in the design specification. So first flush diverters, they divert the first flush of water or rainwater that falls on your roof away from your tank into a separate chamber. So ensuring this first flush of dirty water does not get collected in your rainwater tank, but is separated from it. The first flush contains fine sediments and dissolved particles from your roof. A single first flush diverter should be installed just prior to the entry to your tank. And for a typical household roof, the optimum capacity for a first flush diverter is 20 litres. Now, when you are installing pre-tank, there's a chance that you will be installing charged downpipes. As mentioned before, charged downpipes are where you're running a downpipe that's not near your tank to your tank, and so you run it underground to your tank, and then it comes back up again to your tank. This means that after a rainfall event, water will remain in those lines, which is where the term charged comes from. It's important with charged downpipes that they are flushed on a basis that's appropriate to the area that you live in. Because they are below your tank, there's a chance that debris can build up in charge lines. So you place a drain at the lowest point of the charge pipe, and then that allows you to flush it when you require. Charge pipes may need to be flushed if they're holding water for an extended period of time, maybe 20 to 30 days. And in areas where you've had prolonged dry periods, you may have had water sitting in the lines for quite a while, and the water in the charge lines will just deteriorate in quality. So a charge pipe should be drained typically at the end of a wet season and at the end of a dry season. And areas such as South Australia and Western Australia have those prolonged dry periods, so it's important in those regions to be thinking about ensuring your charge lines are flushed. Then it comes to maintaining this part of the system, the pre-tank part. So a rainwater harvesting system should be considered as an appliance or anything else that you would maintain, like your pool or your washing machine. You need to be aware and take interest in its operation. It's very easy to maintain. The leaf diverters and first flush diverters, if you observe them during a rain event, you can typically see if something's not right, or just be aware of inspecting them prior to a rain event to see if they need any maintenance. It is always worthwhile at the start of every season, which is quarterly, checking your gutters, checking your rainhead leaf diverters, and checking your first flush diverters. And then, as we mentioned before, your charged system can be drained at the lowest point at the end of the wet season, at the end of the dry season. So for rainwater harvesting, there's some key points to understand. The rainwater harvesting systems are inexpensive and easy to maintain. They provide a reliable source of water, and they have greater benefits than just cost savings for households. They save water utilities and governments billions of dollars in capital investment and operating costs by reducing the demand for mains water, which then gives the wider benefit to the community. It reduces stormwater management costs and reduces environmental impacts on our waterways, and over 3 million Australians drink rainwater every day. Drinking quality rainwater is easily achieved through adopting the system design. Rainwater harvesting combined with a mains water service provides water supply more efficiently than either service alone. And this concludes the pre-tank section of the rainwater harvesting design specification. Thank you for your attention. If you have any questions, please direct them to the Rainwater Harvesting Committee. Thank you.